To begin, I'll discuss which types of materials are used for fused deposition modeling printers, or FDM printers. To quickly review, FDM printers push a strand of plastic through a heated nozzle. The temperature of the nozzle allows for the plastic to become soft and malleable and can be printed in the shape of the part. The material must also fuse to the plastic printed on any lower layers. This means there are a couple critical aspects to which materials can be used and how they can best be applied. FDM printers most commonly use a plastic known as PLA, which stands for polylactic acid. This is the material that will be referenced for FDM printers throughout the remainder of the additive manufacturing lessons. This plastic has a few important properties. It can soften at a temperature that's easy to regulate in a 3D printer. It's also a bioplastic, which makes it biodegradable. Its fumes are also less toxic than other plastic types, making it important to consider if the 3D printer doesn't have optimal ventilation. Many FDM printers also use ABS, which stands for acrylonitrile butadiene styrene. This plastic also melts easily and can print very evenly. The main advantage of ABS is that it's much more durable and produces higher quality finished parts. This is because ABS doesn't soften as easily as PLA due to its higher glass transition temperature material property. There are many other plastic types that can be used in FDM printers. This Ultimaker printer primarily uses PLA and PVA for dual material extrusion. However, this model can also print polypropylene, nylon, ABS, CPE, PC, and TPU-95A. Dremel also makes an FDM printer that utilizes some of the most common plastic types, namely PLA, ABS, and nylon. These materials are typically coiled around a large spool that attaches to one of the sides of the printer. This allows for the strand of plastic to feed up and over the top of the machine into the moving extrusion nozzle. Now I'll switch over to discussing which types of materials are used by stereolithography 3D printers, or SLA printers. These printers utilize the process of photopolymerization. In this process, a pool of liquid resin material has an ultraviolet laser that moves and projects the light into the areas that make up the solid model. X and Y scanning mirrors control the position of the laser. The material at this location in the resin pool then hardens and bonds with any other material that's been hardened beforehand. The laser will harden all the material in a single layer, and then the build plate will move in the third axis to work on the next layer. Because the laser shines upward through the resin pool, the part is printed upside down and rises upward out of the resin. The resin used in the 3D printer is designed to have specific characteristics once the laser hardens the liquid into a solid. For instance, Formlabs offers a variety of resin types that produce different solid qualities. There's a standard resin that comes out semi-translucent. There's also a white resin, a tough resin that has added durability, a resin that's castable, which can burn out cleanly without ash or residue while still capturing fine detail and smooth surfaces, a flexible resin used to produce parts that bend and compress, and a dental resin that produces high-quality dental devices in-house, such as surgical guides, orthodontic models, and retainers. These resins are typically loaded into a cartridge that slides into the machine and can be replaced as the resin runs out. With all these resin types available for SLA printers, the limits of creating new parts are ever expanding. You can be confident that your parts will be functional and serve their purpose right away.